Hi, everybody. My name is Ryan, and this is my data set cleaning and visualization project. To start off, my basis of my entire project will be from this data set I found from Kaggle, which is called the Student Exam Score Dataset Analysis. What this did was that it took over 200 students and collected their data with five key variables, which is the amount of hours they studied, the hours of sleep that they got, the attendance percentage, their previous scores, and their exam scores. What all of this did was to find the impact of these different variables on exam scores and the background of it. So how all this data could correlate and how low like a score a student can get to how high they can get. Um, that's what all this is trying to prove. And when we look at my code later, it will show, and my graphs will show that how the correlation and how they all were able to relate to each other. To start off, my data set, as you can see, um, is considered that I found from Kaggle consists of 200 students. And this is what you will get if you were to get my data set or my project, and you can download the CSV file. Um, Moving on to my code. To start off, before we get into my code, I actually want to talk about the challenges that I faced. And the challenges are that when I downloaded this and used this data set for my project, unsurprisingly, surprisingly, actually, there were challenges I ran into, but the main challenge was that it was actually a very clean data set. So there were actually not a lot of values missing. There were not a lot of duplicates, so that made it hard for me to do cleaning. However, it was not impossible because I did overcome that challenge by creating three performance categories, which is a low, medium, or high to display comparative analysis. So it took, for me, for my cleaning, over it took all the 200 students and it categorized each and every single one of them either as a low test taker score, a medium test taker score, or a high test taker score based on the five different variables for each student. And that is how I resolve that. So moving on to my code, I use pandas and matplotlib as the main imports to create the data, which is pandas, and then matplot to create the graphs. And then this is me loading the data set and then creating a clean copy so it doesn't mess with the original data set copy, which is a good data set cleaning practice. And then this is my code in creating the three different performance categories, low, medium, or high. And then starting off with all my code, one, two, three, four. I created four graphs, and as I created more, it actually became easier because I found a pattern, which was just using PLT and then use it when you have the title, and each and every single graph has a title, an X and Y axis label, and a grid. So when you have those, most of the work is already done, and it's just finding the right label and the names for it, each and every one of the commands or for every different graphs. So that made it easier for me as I went along in practicing that. Let's move on to my graphs. To start off, I have a scatter plot. And this scatter plot shows the amount of hours studied by students versus the exam scores they got. So the impact on what it had was that students that studied less, around two, four, tend to have a low score. And then for every dot that is considered a student, those that studied more than 8 or 10 and up to 12 hours, they got one of the highest scores out of all 200 students. The main takeaway is that students who studied more had higher scores. And then if those who studied more than 8 hours also had scores above 35. The second one was a histogram. The histogram showed the score distribution for every single student. So if you scored a 35, that all the students that had a score of 35 is shown right here. There was over 20. And then my th- um my third graph is a pie chart. So it divided and sectored off every single the amount of the 200 students. Out of all the 200 students, how many of them were as a percentage? So if they were a low test taker, 29% of them were low test takers out of all the 200. If you had a high score and you were a high test taker with exam scores, 19% of that consisted of the 200. However, 52% of them were medium test score takers. So that really just showed that it was like a bell curve. And that, however, you don't see that visually until you move on to um, the histogram as I showed, but also the bar. The bar chart shows that it compares like the different average scores between performance groups. So if you were a medium in the mediums group, roughly the average score for those that were in the medium group were around 35 versus the average score that you found from high test takers of the 19% were more than around 45. And then the low test takers, those that are considered low test takers, the average score you found for each of them were 25, give or take. And overall, the main key takeaways from the data set and the graphs was that those that study have like a lot of study hours had strong positive correlation with exam scores. And also the previous scores tend to be the best predictor of success. That's your best correlation. And then high attendance, like those with 80% or more, had better outcomes. And high performers tended to have high study hours, sleep that they got, and overall just better previous scores and high scores. Thank you for listening, and that was my project.